Okay, so logical concepts, great for figuring out how people think. Natural concepts, these would be things that actually exist in the world. And most natural concepts have what we call fuzzy boundaries. It's really hard to tell where one concept leaves off and the next concept picks up in natural concepts. Natural concepts tend to have prototypical examples because these are concepts that people have developed over their lifetime and their experiences with the concepts. And so they have established in their minds a great example of that concept, that prototypical example. Natural concepts are probabilistic. What that means is that in your experience in the world, you have developed your concepts based on how likely it is that this particular object out in the world is an instance of that concept. Like you've been going through life like a little statistician, figuring out member of the category or not, member of the concept or not. You use for example, the availability heuristic to determine whether a current example is likely or unlikely. For example, in the availability heuristic, you say, if I can think of it really easily, it must be really common. So if I say, think of a chair, the first thing that pops into your mind is your prototype. And then you justify that being your prototype by saying, well, I must have seen a lot of chairs in my life because it was really easy for me to think of. So they must be really common. That this style of chair must be really common. So that's what we mean by availability. The probabilistic nature is that, if it's available, if it's easy to think of, it's probably because you've had a lot of experience with that instance. So here's an ambiguous figure. You probably are seeing one animal first, or you saw one animal first and then ultimately realized there were two possible interpretations. You might be seeing a duck, just the head of a duck, or you might be seeing just the head of a bunny rabbit. The duck is looking to the left, so his bill is pointing to the left. The bunny rabbit's looking to the right, so his ears are pointing to the left, but his little nose is pointing to the right. They share the same eye. One argument for how you categorize this ambiguous figure is based on how often you've seen ducks versus how often you've seen rabbits. That's one argument or one explanation for which one you saw first, is which one was more available to you? Which one have you had more experience with? The representativeness heuristic is another probability issue. So when you're talking about concepts, the fact that you have a prototype means for that concept, if something out in the world represents that prototype really well, then you're going to assume that that is a member of the concept because it's matching the prototype really well. So here's a object out in the world. And your job is to say, what does this man do for a living? If you said professor, or maybe lawyer, or librarian, or something bookish, you probably were relying on your representativeness heuristic. You don't have much to go by here, except for how he looks and what he's holding in each of his hands, right? And the fact that there are elbow patches on his jacket and some other things, right? If he really closely represents your prototype for a professor, you probably said professor. If he really closely matches your prototype for a lawyer, you probably said lawyer. That's the idea, right? So you're playing probabilities when you're saying, I don't know anything else except for about how this person looks. I'm just going to say, of all the people in the world that I've ever seen, he looks the most like the ones that I've seen who turned out to be, at least on TV or the movies or something, a professor or a lawyer or whatever I'm thinking, right? So that's what I mean by probabilistic, that, based on your experience, you make judgments about whether the instance matches your category. All right, so there are a variety of different categories. There are categories that are based on verbal context. So we're going to use the category of drinking implement, drinking container, as our example, and that's because there was an experiment that used these stimuli to try and see how people categorize. And in the neutral condition, the subjects were told to name whatever object, and they were shown the objects one at a time, and they were supposed to name the object. What is that? In the context condition, they were told, imagine that it's full of mashed potatoes, or imagine it on a dinner table, or imagine drinking coffee from it, right? So they were giving some kind of context. So what they found is that there are fuzzy boundaries for this concept of drinking container moving into bowl, right? And if you look at the objects, some of them look like very stereotypically something you would drink coffee from, and some of them don't. Like the triangle one is really, that one really stumps me. I don't know how you would even drink out of it. Like, where do you put your mouth? It looks very horrible. But like the top right one, number 4, if you imagine mashed potatoes in that one, or maybe number 3, that would make a lot of sense. Imagining mashed potatoes in number 17 doesn't make a lot of sense. So you'd have a lot of trouble trying to name the object given those kinds of contexts. Now, if you were just told name the object, you'd probably with number 1 start off very confidently saying cup. And by number 9, if you're going down that column, by number 9, you might be at like, I don't know, is that a vase? Number 15, very similar in shape. Some of those, are those vases? Like, what is that? 16 and 17 kind of look like wine goblets of some sort, but why do they have a handle on it? So you can imagine in the neutral context, people probably had difficulty also. And that's where they were able to reveal these fuzzy boundaries, like the transition from clearly a cup to something else is kind of fuzzy. Like, at what number would you say it's moved into something else? So categorizing is not always quite as simple as we think it is. A lot of times people, when they're revealing that they are experiencing a fuzzy boundary, is that they'll use what we call a hedge to explain it. In cognitive psychology, when we say hedge, we almost always mean it's sort of like, is what they said. So maybe they're looking at number 8 and they're like, well, it's sort of like a cup, but it's just a lot taller. So I guess it's basically a cup. That kind of hedging shows that they've got these fuzzy boundaries. There are linguistic contexts and judgments that help us to reveal that there really is no consistent set of exemplars or a single prototype for any particular concept. Like, we haven't all agreed on what the exemplar of a concept is, or what the single prototype is for a concept. So the example that you've been presented with, its representativeness is going to be based on the linguistic context that's been provided. So like semantic categories. So we would say a chair is furniture, a rocking chair is furniture, right? We can put those things together really easily. Family resemblance. So under the superordinate category of furniture, we've got chairs and tables. And then under those, we've got those coordinate levels of rocking chairs, recliner chairs, dining room tables, bedside tables. We would have to look for the family resemblance among the members to determine what category it belongs in, right? Rocking chair is a tricky one because it's got 4 legs, but it's got those rockers on the bottom of it, right? So it's like, is it a chair or is it a ride? Like, what is it? It's got all the characteristics of a chair with the addition of this movement that's not, typically on a chair, we don't want movement. So it's a strange example, right? Or a recliner that can tilt back. That's not normally part of what you would expect out of a chair. So I put some unusual examples just to sort of illustrate the idea that there is no set prototype or exemplar, and that a lot of times there are details that don't match, and somehow we still figure it out. The subordinate category members tend to be easier to visualize than the superordinate. Like, furniture is a really hard thing to just sort of visualize. Like, how do you think of the concept of furniture? But you can visualize a rocking chair. You can visualize a dining room table. So that's one of the ways that we can kind of tell, the level that the person's processing the information at. So putting this all together to try and make sense of all these things that we've talked about, your semantic memory contents, you've got the procedural memory, the propositional memory, and then this evidence of expertise that emerges as a person becomes really skillful at managing the contents of their semantic memory, at least with regard to their area of expertise. Semantic memory structure, we've got different models that attempt to explain the structure of semantic memory. The teachable learning comprehender, the TLC model, assumes these hierarchies that we're trying to go for cognitive economy, and we have this evidence for category size effect. With the spreading activation model, we've got these interrelated nodes with distance determining the strength of the nodes, and then the feature set theory where we match individual features to their categories. Each of these models explain part of memory and things that happen and leave something unexplained. And then we've got the logical versus natural categories issue where, really when we have these experimental designs where we impose a logical category, it really reveals the structure of categories. Even natural categories, when we show people crazy versions of what could possibly be a member of the category, we get evidence that we've got fuzzy boundaries in natural categories. And that the development of categories is really very probabilistic. And we see that through the representativeness heuristic and the availability heuristic being brought into play as people attempt to categorize individual instances into their proper categories. So hopefully this all brings a little bit of clarity, at least, into the idea that you do have this semantic memory store, that you do have information somehow structured within it. It's probably a little less than satisfying to walk away going, I still am not really clear on how it's housed. And that's a function of, the fact that we haven't really settled out which model explains the memory the best. But anyway, I will see you in the next chapter, and we'll move on to a new topic.